Okay, 10-3 is properties of logarithms. So the first property we have right there is called the product property of logarithms. And the product property of logarithms says that I have log base b of m times n. Then I can pull that apart and write that as log base b of m plus log base b of n. It also goes both ways. Remember, equality works both ways. So I could have log base b of m plus log base b of n, but then I could squish it together with log base b of m times n. Alright, so sometimes I don't always have my calculator with me, and sometimes I need to use other things to approximate logarithms. So, for number 1 there it says, use log base 5 of 2 is approximately 0.4307. Let me show you where they got that number. That means that if I were going to take 5 to the 0.4037 as an exponent, I should get about 2. And if we were rounding to 4 decimal places, I would indeed get 2. Okay? So that's where that guy comes from. But it says use that. If we know that, then can I approximate the log base 5 of 250? Okay, so what are some things that I could use? Well, I'm trying to use that product property. So I'm trying to rewrite 250 using the numbers 5 and 2. Okay, so log base 5 of 250 is the same thing as log base 5 of 5 to the third power. 5 to the third power is 125 times 2. Okay, well, I'm multiplying things, so I can separate this guy out as log base 5 of 5 to the third plus log base 5 of 2. Alright, and we had a trick that said if those two were the same, then it just equaled the exponent. So log base 5 of 5 to the third is 3. And we know the decimal approximation for log base 5 of 2 being 0.4307. So I can add those two together and get 3.4307. Now, let's check it. That means that 5 to the exponent of 3.4307 should be about 250. And there it is. Okay, again, we're approximating it. It's not going to be exactly. And we also have it going out to 4 decimal places. So yeah, it's pretty close. It's about 250. Okay. The quotient property of logarithms says if I have log base b of m divided by n, then that would be the same as log base b of m minus log base b of n. You can also think about logs behaving as exponents too. So when I'm multiplying, I add my exponents. When I'm dividing, I subtract my exponents. Okay, so they gave us 2 new ones. They said use log base 6 of 8, which is approximately 1.1606, and log base 6 of 32 is approximately equal to 1.9343 to approximate the value of log base 6 of 4. So what are numbers I can use? I can use 6, I can use 8, and I can use 32, and I can multiply and divide those numbers in order to equal 4. Okay, well, I know that 32 divided by 8 is equal to 4. So log base 6 of 4 is the same thing as log base 6 of 32 divided by 8. Okay, well then my quotient property said if I'm dividing, then I subtract. Okay, so this is log base 6 of 32 minus log base 6 of 8. Well, I have a decimal approximation for log base 6 of 32 is 1.9343 minus log base 6 of 8 is 1.1606. And we can subtract those. 13 minus 6 is 7. 3 minus 0 is 3. 13 minus 6 is 7. 8 minus 1 is 7. 1 minus 1 is 0. 0.7737. The power property of logarithms says log base b of m raised to the p power is, if I bring that guy down out front, p times log base b of m. I call this my come on down rule. Okay, he comes on down out front. So anytime you have an exponent, he can come down out front as a coefficient, or he can, coefficient, or he can go back up as an exponent. All right, so it says given log base 506 is 1.1133. Again, 5 to the 1.1133 is 6. Approximate the value of log base 5 of 216. So I can use the numbers 5 and 6, and I want to rewrite the number 216. Well, I know that 216 is 6 to the third power. So this is log base 5 of 6 to the third. And then my come on down rule says, or my power property rule, he can come down out front. So this is 3 times log base 5 of 6. Okay, well, we know a decimal approximation of log base 5 of 6 is 1.1133. Multiply that guy by 3, 3.3399. Okay, so what good are these rules? So we can approximate decimals? No, not necessarily. Remember when we were doing 10-2? If we had one log on each side of the equal sign with the same base, then we can get rid of it. Okay, well, if you look at number 4 there, I have 4 times log base 2 of x minus log base 2 of 5 equals log base 2 of 125. I have 2 logs on this side. I have a coefficient out front, so I can't get rid of the log. I could add this log to this side, but that doesn't do me any good either because now there's 2 logs on the right side of the equal sign. So think about what we're trying to do is we're trying to squish these guys together and use these rules from this side going this way so that I could have 1 log on each side. Okay, so here we go. I have a coefficient out front. He's going to go back as an exponent. So I have log base 2 of x to the 4th minus log base 2 of 5 equals log base 2 of 125. Okay, well, I now have a minus sign. And a minus sign says I can squish it together with division. Okay, so log base 2 of x to the 4th divided by 5 is equal to log base 2 of 125. Now, I have 1 log on each side of the equal sign. They have the same base, so I can get rid of it. So x to the 4th divided by 5 is equal to 125. Let's solve for x to the 4th, so I'm going to multiply by 5. So x to the 4th, 125 times 5 is 625. All right, I want to undo the power of 4, so I'm going to take the 4th root of 625. If you still have your chart around, you can use it. Remember, anytime I take an even root, I get a plus or a minus. So the 4th root of 625 is 5. Okay, now let's check things, because we do have to check our answers. We can't take the log of a negative number. Think back to when we were graphing them. The logarithm graph didn't cross the x-axis, okay? It never went into the negative x's. So I can't take the log of a negative number. I can't have a base that's a negative number. So we only get the positive answer. Technically, we got a plus or a minus. However, the negative doesn't work because we can't take the log of a negative number. That's not in our domain. Okay, let's try another one. Number 5. log base 8 of x plus log base 8 of x minus 12 is equal to 2. Okay, so I've got two logs. I see a plus sign. I'm going to squish it together with multiplication. Okay, here we go. Log base 8 of x times x minus 12 is equal to 2. Or you can think about that if we distribute it as log base 8 of x squared minus 12x equals 2. But now we have a problem. I don't have a log on the right side of my equal sign. I don't have a log base 8, so I can't get rid of it. Okay, well this is logarithmic form. Anytime you get stuck and you can't get rid of the log, let's change them to an exponential form. So, I got stuck. I don't have a log I can get rid of on the right-hand side. I'm going to change this guy to exponential form. 8 to the second power is equal to x squared minus 12x. So 64 is equal to x squared minus 12x. Or 0 is equal to x squared minus 12x minus 64. Okay, let's see if this guy factors. A minus and a minus is a minus and a plus. I need two numbers that multiply to 64. And subtract to give you 12. You want to think about it as negative 64 and negative 12. That works as well. 16 times 4 is 64. 16 minus 4 is 12. I need a negative 12, so I want a negative 16. Zero product property says I can set each one of those equal to 0. So x equals positive 16, or x equals negative 4. Now, technically we got two answers, but do both of them work? I can't take the log of a negative number, and I can't have a negative base. So we're going to go back to our original. If I put a 16 here, he's positive, that's okay. If I put a 16 here, I get 16 minus 12 is 4, that's okay. If I plug a negative 4 in, that guy is now a negative log. I'm taking log base 8 of negative 4. That does not work. I could also plug a negative 4 in here, and I get negative 4 minus 12 more is negative 16, and I can't take the log of a negative number. So even though there were technically two answers, the negative 4 doesn't work, so we only get one solution of 16. Okay? All right. Let's turn the page and look at your homework. All right, so your homework is on 10-3. The first ones, you're going to get decimal answers. Okay? So you are going to use the numbers. You can use the numbers 2, 3, and 5. 2 is your base, 3, and then 5. You can add, you can multiply, divide, and use exponents. But you want to rewrite the numbers 25, 27, 3/5, 5/3, 15. So you're going to use those three numbers and a combination of multiplication, division, and exponents in order to do that. Okay? Then you're going to use the decimal approximation to find them. On the bottom, you're trying to squish these guys together. So you want one log on each side with no coefficients so that you can get rid of the logs and then solve. Okay? If you get stuck, you're going to do like we did on number 5 there in your notes and change forms. Okay? Good luck, and let me know if you have questions.